hugely enjoy. Rauland-Godinez. She has degrees in like everything. I mean, really, horticulture, landscape design. I do woody plants. She's an arborist. Just kind of, a whole lot of stuff.
It's the best introduction I've ever gotten.
And she's done lots of talks for lots of different people. She's a master gardener. And you've worked in the nursery industry. She's worked in the landscaping industry. You have your own business doing consulting still?
A little bit, yeah.
A little bit of that. And now she has, last I talked to you, you had just a new farm with pick your own farm. Fruit trees and all kinds of things. So anyhow, I'm going to let you enjoy her because you will enjoy her speaking a whole lot more than me. So, to you.
I might be loud enough without the...
I think you should be just right for now. Just for now.
Just...
You're good for now. This is more or less to make sure the audio comes through for everyone online.
But I'm realizing now I forgot my cat toy. Okay, I guess we're going to be cat toyless. My cat's always running batteries out on it too. Maybe we're cat toyless. Welcome everyone. I'm so glad to be here. I love doing this lecture every year and I get to shut down my business early so I get to leave. It's great. Cat toy. As she was saying, I used to be manager at the Museum of the Shenandoah Valley, the gardens there. So I constantly talk about the museum and everybody's going, huh? What? Who? What? And I left there because I got married and I met my husband. Yeah, she's going off the trip with this. She knows me. I start pacing and the next thing I know, I'm hanging myself. I met my now husband while I was working there with Master Gardeners. We were invited to a open house at the fruit tree research station there. And he was invited to come to a grafting demonstration, and I had been trying to find someone to teach a grafting class. So as soon as I saw him, I pounced on him and, can you teach the class? And anyway, one thing led to another, and now we're married. I moved down to the Charlottesville area, and he was working for an orchard there. He's done fruit trees most of his life, and grafting, and fruit tree nursery. So when we realized we were going to get married, we opened that business, and currently we still have that nursery. That's Countryside Farm and Nurseries. We're selling about 200,000 trees a year through that, and then we got an old family farm that was in my family since my great-grandmother, and we've started a fruit tree, pick your own farm stand, vegetables, small fruits, everything there. So we're open on Tuesday afternoons, so I get to say, all right, gotta close today, bye. I used to hate winter, now I'm like, November cannot come fast enough. But we should be picking our first trees next year. They're on that site, and first peach trees, and then we'll be doing apple trees the following year. So that's pretty much everything I do now. It's vegetables and fruit trees. But I still love teaching. I love plants. I think everybody should be a gardener, whether that's one pot on your windowsill or 100 and some acres out back. I don't care which, but they both work. Trees are very important in our lives. We all know we need them, and we know we want them in our homes. We want them, around our homes, not in them. We want them in our communities. We know crime is lower when you have communities that have trees in them. Traffic issues are less. There are just so many benefits to having trees around, plants as well, but even more benefits from actually having trees. So health benefits, community benefits, everything. We know our towns and cities and people are better with them. So with that, that's one reason why we have the tree stewards here in this town, is to make sure that this town continues to have great, healthy, wonderful trees. So we love to see you guys here. At the same time, even if you don't go on to become a tree steward, the more you know about trees and the better that you can take care of your own trees, it's all good. It means they're gonna last much longer. We hope, although to be honest, trees usually last a lot longer when humans are not tampering. So, but having said all that, they're amazing, unique creatures. We love them. We want to know more about it. This is a class, so you guys are going to have to talk. It's audience participation. So I'm always asked to come do the first night, and the first night is that really fun stuff called biology and botany and science, and this is usually my joke that as soon as I say those words, everybody in the room, their face starts to look like that. I can't use that joke this time because y'all have masks on, and I don't know what your face looks like, but hopefully we'll get you through that. It'll be fun, it's exciting, it's interesting, it's fascinating. So with that, on your book, we are first going to talk about the definition of what exactly a tree is. We'll go through the tree parts because it's a whole lot easier to talk about trees and do things with trees once you know the different parts. And when you get into pruning and some of those things, you will need to know parts. And when you get into identification, you need to know those parts. And I forgot to bring plants. Shoot. We're going to talk about the growth patterns, how the tree itself grows, then some of the annual cycles, and then this really exciting thing called coated. Okay, any questions for me? If you guys have questions,
Would you like to wear it?
usually they tell me I am plenty loud.
Yeah, but just in case it doesn't come crisp on
Hi.
there. And where would you like to put this?
And you're going to pick up all my coughs and my wheezing. Are we on?
Yep, we're good.
So, if anybody does have any questions, stop me, raise your hand. And it's not so bad in a small group like this, but I'm actually deaf on one side, which means I can't echolocate anything. So if somebody yells out, especially with a mask on, I have no idea where it's coming from. So stick a hand up or something just so I know who's talking. So with that, first of all, what's a tree?
A living thing.
A living thing.
A plant.
A plant.
It has this trunk, basically.
It has a trunk or a couple of trunks.
I'm sorry?
Several trunks. Some of them will have only one
Some of
trunk.
them have.
Yes.
Yeah,
Yes. What else?
I have a lot of those. Gives us oxygen and leaves.
A living filter?
It's a living filter, but I guess what I should be asking is what defines a tree versus other plants?
Oh,
What makes it a tree versus a shrub versus a flower, a perennial, an herbaceous plant?
well, it has an upright form base mostly, but you've got a central trunk or trunks that eyes you have.
What's in that trunk that makes it different from an herbaceous plant, from a perennial, from an annual?
The reins. The,
And the rings are made out of
Cells.
what?
Has cells.
There's cells that, we call that what kind of tissue? I'm looking for a simple term. Woody, very good. Yeah, they're woody tissue versus a perennial that dies back to the ground every year. So trees don't die back to the ground every year, right? Your book definition says size. I kind of on that because I know shrubs that are 20 feet tall and I know trees that are 10 feet tall. So how close did we get? Woody tissue.
so,
In our woody tissue, we have cellulose and we have lignin. The cellulose is what gives it the tensile strength. It's what holds the cell walls up, and the lignin is the compressive strength. So tensile strength is what allows it to move and stretch and bend. Compressive strength is what allows it to bear its weight, so the pressure pressing down on it. And it needs both of those to actually create that woody system that holds itself. Size, this is the one where I kind of differentiated. Some of the official definitions say a tree is 20 feet tall. I've seen is 15. And that was really doing it. The largest one I've really ever seen is 10 feet tall. But there's one actually on our road right beside our farm that, actually it's two. It's on each side of a driveway, and I don't know how old these things, they're the biggest things I've ever seen for Japanese tree. I can't talk. Japanese silver bells. I was gonna stop and get coffee before I came, I forgot. Okay, so here we get into the single trunk or the few trunks, but usually they don't have a whole bunch of trunks, right? It in general does not need things to support it. It holds itself up in general. So, tree parts. Anybody know what that is?
Canopy.
Canopy. How about these?
Limbs or branches.
Branches.
It's the hard side.
This, I know, isn't this hard? Come on, guys, this is botany. What's, oops, push the button. What's that? And what are these down here?
Roots.
Okay, wasn't that hard? Yeesh. So, what do roots do?
Gives it water, or nutrients from the ground.
Both
Oh.
water and nutrients in the ground. Now, I am ashamed to say how old I was before I realized, I sort of had it in my head that you have nutrients in the ground and this giant mouth kind of opens up on the root and sort of encircles it and sucks it in. I'm really embarrassed to say I was far older than I should have been before I realized, no. They take in water. So all the roots take in water. The nutrients that they take in are dissolved in the water. So I'm sure somebody else out there has that same theory as me that, you know, or, you know, a little hand reaches out, and, but not really. Okay, so it takes in moisture, it takes in nutrients. What else?
Provides support
Provides support.
and stores nutrients in the off-season, whatever that may be.
Good. Stores nutrients in the off-season. Stores a few in the in-season too, but stores a lot in the off-season. Any more?
Oxygen.
Oxygen. Creates oxygen, takes in oxygen. What with oxygen?
Nitrogen.
Mhm.
From the water.
And from the air. Well, the root, from the soil. I'll go ahead and get this out here. If you learn nothing else from this class, roots only grow where there's air and water. If there's no air and no water, they don't grow there. So when you see roots growing on the top of the ground, sometimes there are trees that naturally have more surface roots than others. But usually if you see roots on top of the ground, you have really crummy soil and there's just no oxygen in the soil, so they come up. How deep will roots grow?
As tall as the tree.
One answer, as tall as the tree.
18 inches.
Second answer is 18 inches. Any more takers?
I'm sorry.
Some taproots of 100 feet down. Some won't go more than the width of the tree.
18 to 24 inches. Because roots grow where there's air and water. Now, we all grew up, most of us grew up, seeing a picture, the diagram of the tree, and you had the tree on top of the soil, and then you had the line where the soil was, and then you had exactly the opposite flipped down, and that's what the roots are supposed to look like. We all learned that in elementary school. That's not at all what a tree looks like. And then when they were first studying trees, they saw the big taproot when, there's your taproot, as it's first growing. So your seedlings would grow this big deep taproot that would be several feet deep, actually. And we just assume that means that that tree grows with a taproot. So we are still taught that certain trees will have taproots. A lot of conifers, they tell us, have taproots that grow really, really deep. And then other deciduous trees have more broad roots. All trees will grow some taproots to get it established when the seedling first starts growing. And then as it ages, it starts putting out these lateral roots, and it'll still sink. And they're called sinker roots instead of tap roots nowadays. And it plunks those down several feet, again, for anchorage. But the tree doesn't grow one big tap root that goes way deep. And we're all taught that, but it's not true. And as they age, that first tap root actually will usually get girdled by the other roots. And it will kill that first one and then start putting out more sinker roots as the roots continue to grow outward. We also have the theory, and they used to believe this, that the roots will grow out as far as the drip line of the tree. We now know that the roots very often in an older undisturbed tree can go 3 times as far as the tree is tall.
Oh, outwards.
Outwards.
Oh, okay.
So when we say, oh, feed your tree at the drip line, that'll take care of everything you needed to take care of, that's not really true if you're talking a very established tree and an undisturbed tree.
Toxins so that it doesn't taste good, or it's poisonous to that insect, or it makes it very bitter. We know that the tree at the other end, whether it's the same species or a different species, will start producing those same toxins even if it has not been attacked yet. How cool is that? And then we also know that in forests, if there is a lack of water, nutrients, sugar, that's been a bad year, resources are not good, trees will share resources. So if you have a big, well-established tree, it will start sharing sugars with some other trees around it. And we also know that it actually will give preference to its own progeny. So if some seedlings have grown up, and we have no idea how the tree knows this, but the tree knows this, if the seedlings, some seedlings have grown up around it, it will feed those seedlings first, and then if it still has resources, then it will start sharing with other species. Is that cool? That's so cool. This is why I love trees. Okay, back to roots. What else? They haven't read their books yet. Did they get books this year? Online. Y'all haven't read your books yet. Shame. Absorption, back to that water and nutrients. Conduction means we take those water and nutrients from the tips. We used to call them feeder roots. Now we call them absorption roots. Those are at the tips of the root zones. When you look here at those tiny little fine hairs, this is a seedling, yes, but that's at the tips of all of the roots. That's what's growing. And each of those hairs is actually one cell that has grown out. Those hairs are very porous, so moisture can go in. Moisture can also go out. So if we're in a drought, the ground is drier than the moisture in the roots, the water will go out of the roots too. So you have to be aware of that. That can damage our trees. If you create an area, salt will actually lower the conductivity of water. It makes it a lower, I'm not thinking words tonight. If there's a saltier area outside, the water will leave the roots and go outside of the roots, even if it's not necessarily a drought situation. So if you are misfertilizing with a fertilizer that contains salts, you can actually cause the water to leave the tree. That's what's called burning the tree. Okay? Conduction, once it takes in nutrients and water, then it transports them to the center, and we call them conduction roots. If you go back, so our feeder roots or absorption roots are at the tips here and here. These are coming towards us, not down. And then these are the conduction roots. So they're taking the moisture and the nutrients up and up the tree, right? Storage, we talked earlier. They store our sugars, starches, hormones. They also, we're discovering, I think I put this, yes. Part of that defense system, we are also studying trees. You have a branch, some aphids come onto that branch and start attacking that tree, or some caterpillars come and attack that tree. The tree immediately puts out chemicals right there, or hormones. And the hormones, first of all, it puts off hormones that says we're under attack. Then it puts off some more hormones and growth, not growth regulators, hormones, that, as I said, will produce toxins and produce poisons and produce alkalis and different things. So it makes that plant less tasty to the insects and can also poison the insects. But those insects could move to some branches around that one, right? So they're finding out now that very shortly after the toxin or the hormone that says we're under attack, that one gets released. These other branches are also putting out the same chemicals, alkalis, toxins, to protect those branches before the insect ever gets to them. But when they've studied it, there's no way that those hormones could actually get from the tip of the branch down to the trunk and back out to the other tips in the amount of time that it takes those other branches to start producing those same hormones. And what they've figured out is actually the gases that are produced, usually by the roots. They produce ethylene gas. The ethylene gas is what causes our leaves to start to change and fall. Ethylene gas also rises up around, and it turns out they believe those hormones are released in that ethylene gas. And once the other branches around it smell that ethylene gas with the hormones in it, that's what triggers them to start producing those chemicals. And again, other trees around it, even if they're not grafted together by roots, they also will start producing those same hormones. So they get the ethylene gas, smell that there's hormones in it, and start producing those toxins as well. On the flip side, one of the things that my husband and our company does is if somebody has a fruit tree orchard, they want to change over the variety of their orchard. Then they call us, and we come every spring and we chop off the tops of the trees and we put new tops on. Well, there's an insect that used to like ornamental trees, and about 10 years ago suddenly decided it liked apple trees. It's called an ambrosia beetle. It's a borer. It carries a fungus with it that is fatal to a tree. There's no fungicide that will kill that fungus. But the ambrosia beetle smells the ethylene gas. So when a tree is under stress, it produces that ethylene gas to carry its hormones and let the whole tree know that it needs to make some changes, chemical-wise. The ambrosia beetle smells that gas and immediately targets that tree. And other insects will do this with other stress hormones in other plants. But it's one that for us, we know now, obviously we're stressing a tree if we're chopping off all the tops of the tree. So we've had to adjust things. We have the people cut off the trees in the wintertime, so we're just doing one small cut when we get there. The main stressor to the tree happens when the ambrosia beetles are dormant. But even then, we will have within 5 minutes of us cutting off the top of that tree. If we're in an area that has ambrosia beetles will be on that stump. It's that fast. So they can smell that chemical and they know to target those plants rather than target very healthy trees. So that too is kind of cool. We use a sealant actually, and we put that sealant on, and as soon as we use that, then the ambrosia beetles can't smell it anymore. There's no ethylene being released through that stub, and so they go away again. But then the interesting thing is if we're cutting down a whole row of trees, we'll see ambrosia beetles on this one. We'll have 8 or 10 trees, and then all the ambrosia beetles are here, and then another 3 or 4 trees, and then the ambrosia beetles. So there's obviously weaker trees within that row, and so they're still attacking the weaker trees. And we actually use the same kind of thing with our vegetables. I don't want to spray my whole vegetable row if I don't have to. I don't want to eat any chemicals if I don't have to, and it's really expensive to spray. If I put in a trap crop beside the vegetables, then I can sacrifice that crop and spray that instead of spraying my entire vegetable patch, right? One of the things that they use a lot for the trap crops is a certain type of sunflower. And we've even discovered that certain weaker sunflowers will attract a lot more insect pests. And so we can actually go down the row, just spray those sunflowers and not even have to spray the entire row of sunflowers. So you can use this to your advantage. They're even doing drones now out west that have sensors that smell the ethylene gas being produced and some of the stress hormones being produced in crop fields. And so they can target using that sensor instead of having to spray the entire crop field. They can use a drone and just spot spray exactly where that gas is being produced. So they're reducing the chemical load and they're reducing their cost and they're reducing all of that. Cool, huh? See, I told you y'all would find these things cool. Any more questions about roots? So, these are those sinker roots I'm talking about. So their sole purpose is to anchor that tree plate, and eventually one will probably come out there. And you can see these are growing out much further. We're at 2 feet. Why are they at 2 feet?
Oxygen?
Oh, yeah, there's oxygen and water.
So roots only grow where there's oxygen and water. Air and water. The other thing about a very porous soil that has plenty of oxygen in it is that it's actually easier for those root tips to get through. Compacted soils, it's very difficult for those roots to break through. Okay, what's that part called? The trunk? That's the trunk. This is the part where the roots meet the trunk.
The flare.
The flare is one.
A knee?
Not a knee. Knees are on,
Oh, the thick branches that come off.
It's
Lateral
called a
branches.
root collar.
knees are usually on swamp type trees, cypress, those. And they don't know for certain, but they think the knee grows up above off the root, and they're thinking that it's an adaptation to allow them to be underwater where there's no air. So, yes, ma'am.
So I think that Ed was pointing to the point where the trunk is literally moving into the root system, so it's like a collar, root collar.
Some people call it the root collar on perennial plants. They call it the crown. It's called the root flare. This is a critical zone. So many trees, if you cover up that zone with mulch, you kill the tree. So that zone has to be open to air, has to be open. You want to see the flare. So when you see a tree that's planted and it looks kind of like a telephone pole going straight in the ground, it's been planted too deep. And it's going to die much sooner than it should have. The other thing here, this is where roots that are designed to be underground and have a lot of moisture up against the bark actually changes right there. So you'll see on the roots, if you see surface roots, you can see the bark is much craggier, thicker, heavier. Again, it's designed to be able to withstand being underground, being under attack by lots of moisture, lots of fungus, things like that. Whereas your bark up above ground is usually smoother, thinner. Granted, when the tree gets a little bit older, it will be thicker and craggier, but you can still see a line where these two barks change. So you never want that line to be underground. At best, it's at the surface. It doesn't hurt if it's an inch or two above the surface, but never, ever, ever below. What was that? I already told you.
What, sinker?
See, this is the sinker root or the anchorage root. What's this one?
Feeder root, yeah, feeder root. Oh, which one?
Right in the middle here. That big thick root. Your feeder roots are going to be out here, right?
Oh.
Out of the tips. So once they go through the feeder root, then they go through which root? Remember, we're transporting that moisture and nutrients from the root.
Conducting?
Very good. The conductive root. And then out of the tips.
Feeder.
And let's not call them feeder roots, because we're not really feeding.
What are they?
We're calling them absorption roots, because what they do is absorb, rather than reach out with that little amoeba-like arm and snatch it up. They just absorb.
That's a fun picture.
I'm embarrassed to say, it was like right before I took this class when that suddenly dawned. So on a root, this is the root tip. So we have the root cap. We'll start earlier. There is a zone right here, and I should have mentioned this earlier, but this is the apical meristem. There's your big word for the day. That's it. Is meristem. Trees are growing in 3 different places. I'll talk about this shortly, but one of the places that they're growing is right on the tip of the root, and this is the only place where they're making cells. Those cells are formed right here. Some are pushed forward, and that creates the root cap. Most get left behind as more cells are produced, and this keeps on growing outward, right? So the root itself is not moving, just the tip is adding on cells. Same way with the tips of the branches. The branches themselves are not growing, just the very tips of the branches are continuing to add cells. We got that picture in our head? Because we all also have that picture that this root is snaking, and then it gets to your house foundation, and then it puts on its little slanting eyes and pointed ears and horns and starts to push against your foundation to break in, right? Those evil trees, we can't have those trees next to our house because they're gonna push their way into our foundation, right? Wrong. So just those cells are growing, just those cells are moving. As they move, as these cells move onward, then some hormones are produced that make those cells get bigger, and that's the zone of elongation. And then as you get further away, there are more hormones that are produced. That is the zone of maturation. That is the zone, it's also called the zone of differentiation. That's where it is decided what that cell is going to be. So some will become the epidermis, the outside layer, that have those little root hairs coming out of them. That's all the same cell. Notice there's no wall right there. That hair is part of that cell. Some will go on to be the, I'm losing my mind. The xylem and phloem cells, some will grow on to become the cambium layer, and we're going to talk about those other two when we start talking about stems. But that's where that happens in the root. Okay? Clear on that one? Mm-hmm. I don't remember why I had that picture. Okay, so the trunk. What is the function of the trunk? Are we taking a break?
Yeah, about 8 maybe.
What's the function of the trunk?
Support.
Support. We got to get all that stuff that's in the roots up to the top of the tree, right?
Oh, it delivers the water.
Conduction.
Yeah, conduction.
And it also takes the stuff from up in the top of the tree back down to the roots, right?
Oh, right,
cambium,
from the leaves.
Mm-hmm.
So supports the cambium, actually transmits the water and nutrients.
Mm-hmm.
It's
What else
really
does it do?
incredibly fast. It's one of the most amazing things I ever saw demonstrated. When I had a tree treated for the emerald ash borer, and I watched how quickly the tree took up that medication. It's incredible.
The other thing I'm not going to tell you yet, but when we get to xylem and phloem, this will be your teaser. Giant redwoods.
Could you repeat that? I haven't.
Giant redwoods.
Oh, yeah. They're incredible.
There's your teaser. We'll talk about them in a minute. Don't let me forget. Trunks. What else? Has anybody ever walked into an old house that had heart pine or hard pine floors? You'll hear it both
Oh,
ways.
they're incredible.
The rings.
What causes heart pine to be heart pine?
Center of the tree.
It's the center of the tree. What do you think the center of that tree is used for? So a tree absorbs water. Dissolved in that water where I come from is limestone. It's rock. That's why we have all those gorgeous caves. That's why I can't keep a coffee maker longer than 6 months. Because stalactites form inside my coffee maker because there is so much limestone in the rock we could chew our water. The tree's taking that in as well.
Because of the color.
It's
The
taking
color of the
in,
wood.
so it's taking in rock. Right.
The minerals, that's what gives the wood a different color than the trees.
Kinda, sometimes yes, sort of.
Okay.
A tree has no use for rock. It's not going to help its functions, it's not gonna help it grow, it doesn't even help it be stronger, kind of. So what does it do with all that excess rock it doesn't need, or any other minerals it takes in? It stores them, right? Where do you think it stores them?
Cells.
Of
The trunk.
the trunk. So heart pine
Why do they
floors,
store it? Why does it need it? Why does it store it then? Why does it?
because it has no place else to put it.
Okay.
It's inside the water, it can't use it, it doesn't really have a trash can,
So excess.
it can't poop.
Where do you see it then?
So it stores its excess pollution, its excess nutrients, excess things it doesn't need. It just tucks them into some attic rooms, never to be opened again. Those would be the center of the trunk. And heart pine is so hard because it's the big, huge old trees. You don't get it anymore. But it's 100-year-old trees that are big enough that you can make boards out of that center portion. But it's actually rock and minerals and all this stuff, pollution that's been stored in the center of the tree that's made it rock hard because it's full of rock. Okay? So the center of the tree is basically the tree's trash can. I don't remember if we did them all, but support, we got that one. We're transferring all those waters, nutrients, sugars, hormones, anything that's got to go up and down. We didn't mention oxygen transfer. Have you seen trees that have those little polka dots on the bark, especially cherries, have lots of those little dots in the bark? They're called lenticels. You'll see it on princess trees or empress trees. There's some trees, it's an identification thing. They're very obvious in some trees, and those are actually pores to get oxygen into the tree.
Really?
And I say oxygen, not carbon dioxide. Because we all are also well versed in the fact that trees take in carbon dioxide and put off oxygen. Do trees also need oxygen?
Yes.
Live, with the exception of one subset of creatures that live in the bottom of the ocean in the sulfur vents. They are the only creatures in the world that can live on sulfur instead of oxygen. Everything else that's living in the world has to have oxygen. Cells have to have oxygen. So we have to get oxygen into the trunk, into those cells, as well as the rest of the tree. So those pores, those lenticels are there to do that. How about protection? Does that trunk help protect the tree?
Oh, sure.
By storing those pollutants, that's one form of protection. It's got that nice bark covering on it to help protect it from insect and disease. Storage we already talked about. Okay, the parts of our trunk, we're going to do this circle here. This is looking at the cross section of the tree. The trunk, what's the center part?
The heart.
Before it becomes the heart, what is it?
The center?
Oh, sorry, I'm going the wrong direction. All right, I'll tell you. It's
I knew
pith,
Is it?
the pith.
Oh, okay.
When that first branch first starts growing, it has the pith first,
Okay.
and then it starts to create the cells around it. I always think I'm going from center out, but then I realize I'm going from out in. So the outer portion is the court cambium. What's the other word for that? The bark. What's the next layer in? That thin green line when you scratch
Xylem? Isn't that the-
bark? It's not xylem yet.
Epidermis? No, no.
What's the other? Not xylem, but
Phloem?
phloem.
Oh,
You're seeing phloem, and you're also seeing what's called the vascular cambium. This is the other layer that's growing on a tree. So we got two parts, right? We got the tips of the roots that are the only growing part of the roots, and we have the vascular cambium. So the vascular cambium is right under, we have the court cambium on the roots too. That outer layer, the epidermis, the outer part of the root, then you still have vascular cambium growing there. So it's like a tube that encircles everything. And then we have, what's the next one in? Before the pith. From the vascular cambium, what's right inside of the vascular cambium?
that's why.
You can steal it from him, he already said it. Xylem. That's where your rings are. And then the last one is the pith. Okay. Xylem are cells that are tubes. They have no ends, they only have sides. Water goes up and nutrients go up. They only go one way. So they take moisture from the roots up. Phloem are tube cells as well, but these have little end caps, and the end caps have holes in them. They're perforated. So moisture can go up and down. So the one of the things is the phloem, water flows down. That's one way to remember it. And we used to think that all the moisture went up in the xylem and all the moisture went down in the phloem, and now we know it actually goes up and down in the phloem. And those walls help with that. Now, here's where the interesting thing is with giant sequoias and the giant redwoods both. If you take the pull of gravity, or the push of gravity, and the push of the water, it's actually physically impossible for the water to get to the tops of those trees. They have no idea, according to the laws of physics, how water gets up there. Same way, we have no idea, according to the laws of physics, a bumblebee can't fly. Same concept.
Kind of leading into that, I remember how the phloem works to transport. How's the xylem? What's the pump, the pressure, what makes it flow?
Well, I'm so glad you asked.
Okay.
I'm not going to answer that quite yet, I don't think. I'm not going to answer that quite yet.
Okay.
We'll hold that thought. The question was, how does that happen? It happens because of adhesion and cohesion. Water sticks to itself and water sticks to other things. That's one of the ways that it happens. So water sticks to the sides of the walls of the cells, and water sticks to itself. So if you get part of it going, it's pulling itself along. I'll give you that much, and then we'll talk about more of it when we
You'll
get to the
touch
leaves.
back with redwood when it's 200 feet tall, and the weight of the water at the bottom is multi-foot-pounds per square inch, and it still manages to push. That one
So
I
you
never-
do have that push process.
Uh,
You've got moisture coming in from a high moisture area to the dirt, soil, into a lower moisture area, which is the roots. And then it's being conducted,
you get the Venturi effect there.
pushing, but then you have the other end, which we're going to get to in just a minute. We all clear on xylem, phloem? I'm getting there, hurry up, back in 6 minutes. So this is looking at a trunk cross section. So your bark, underneath that bark, you can't really tell it here because this one's been chopped down, but there would be a thin green line right in there, and that would be the vascular cambium. It can be 3 up to 20 cells thick. And on this side of it is the phloem, and that will be a few cells thick also.
Reduced, and those are being pushed towards the inside of the trunk, and that pushes the entire trunk outwards. Normally at this point, we all get up here and we play a game, but since we have to socially distance, we can't do it. So go ahead. The only... You will sometimes hear tree professionals say that they're going to come and deadwood your tree. If they're going to deadwood your tree, they need to chop it down at the ground. The only living part of this tree is the xylem and the phloem, not even the phloem, the vascular cambium and the 2 meristems at the tips of your branches. Those are your only growing points. All of this technically is dead. Your bark is technically dead. So the only truly living part here is the vascular cambium. This one you can kind of see that heartwood, and this is where I was saying kind of. You see some discoloration. We used to think that the tree only used the outermost layer of xylem. We know now that it'll come 2, 3, 4 layers in, but it's not really using this inner portion except for storage of pollutants. Branches, we're going to do these really quick. So at the other end, we have the terminal bud. This is where the apical meristem is. So same as the roots. Same thing up here. So it's this bud that's the actively growing part of this branch. The branch is not growing back here. It's only growing right there. And this bud, where it's growing, is only making more cells up here that are slowly working their way outward. Okay? So, terminal bud, you have lateral buds. And the place where your buds are is called the node. Each place where you have a bud, node, node, node. The places in between the nodes are called the internode. We care about this because there's lots of hormones at the nodes and at the terminal bud. There are not many hormones here in the middle. So when we're pruning, we want to prune at bud unions because that's where the hormones are that are going to help cover over that wound. Right here, because this was once a bud, so there is still hormones there. Leaf scars we care about. That's where the leaf was and then fell off. It's one way that we can identify a lot of plants. The flower bud scar, if there was a flower there, there won't always be a scar there. It depends on the type of tree. But if there is, that's another way that we can identify trees. Here's the pores that I was talking about. These are the lenticels. You will see terminal bud scars. That's where this bud was last year or 2 years ago. Here's a scar there. So the bud was here. This grew last year from there. So that's a terminal bud scar. And the year before, it grew from here up. Is that clear? Sometimes these are not real easy to see, but it's another identification point. Yes, sir? The branch is growing thicker because it still has the vascular cambium around it. Yes. Yes. So the branch is getting higher in diameter, but the tree is not growing. When the tree's getting taller, it's getting taller because it's growing here. It's not growing up out of the ground I actually had a professional that came and told me I needed to cut down a tree that was growing through the fence because in another 5 years, it will have lifted the fence up off the ground as the tree grows. Yeah, it'll mangle my fence, but it won't lift it out of the ground because it's not growing down here where the fence is, it's growing up here, right? I shouldn't tattle on my coworker. So we're clear on these parts. The other thing is if you're ever making new trees and you want to cut off a branch and root it, where it's making roots, again, is where that node is. So you don't cut and expect most trees to make roots where the inner node is. Some trees will do it, but it's not a good thing. It's a bad thing. Okay? Leaves. What do leaves do? I'm getting close, I know. I think my break is right after this. They make sugars for the plant. And what is photosynthesis doing? What's its purpose? To make yeah, most of your photosynthesis happens there. What else? This is where the other half of the water issue comes. They're evaporating. So there's pores that are in your leaves. The pores open up on warm days, and there's big spongy cells inside. They're making hormones and storing sugars as well. They're intentionally losing water. I'm trying to get there. So this is the crossleaf, and there's lots of these cells that fill up with water, but there's lots of air pockets in between these cells. Then you have the vein that comes through. This is the leaf vein. And then you have these pores that open up to open areas inside this cell. And so when it is perfect conditions, these guard cells fill up with water, which causes them to open. And when they open, it causes the water that's inside, the moisture inside this leaf, to evaporate out. And remember, water moves from high intensity areas into low intensity areas. So if we're losing the air, there's more water inside the leaf than there is in the air. Your water is going to evaporate out into the air, at which point this has a lower amount of moisture in it, so the water is going to come out of the vein and go into this area, and we've just created a straw, right? Because all of those veins are attached through the xylem and phloem back down to the roots. And so you've got your leaves that are pulling the water at the same time you've got the moisture pushing from the bottom. That's how it supposedly gets to the top of the redwood. Thank you. Again, once you add gravity to it and all those good things, it's impossible for it to happen, but it does. Okay, we're going to take a quick nap. You'll have leaflets coming off of it, and then you'll have, these actually are the leaflets. So you have this petiole, you have this petiole, and then the leaflets on the petiole. On a Kentucky coffee tree, you will have one more of these coming out here with leaflets off of that. So a single leaf on this tree will be anywhere from 3 to 6 feet.
Oh, wow.
So it's a great thing for education because you don't see a lot of this is bipinnately compound. So 1 here, 2 here. So the tripinnately, there's a fern that does it, but there's not very many plants that do that. So it was great for educational purposes, and then I moved away. And I left my tree behind, and I hope they haven't cut it down. I haven't been to look because I don't want to know. But they've done lots of renovating there, so they've chopped down lots of things. And planted more back. And the other one that I love is the Seven Suns flower. The, I'm just not thinking tonight. It's a small tree. It is a multi-stem tree. It has white bark that's exfoliating, but it exfoliates vertically so the bark peels off.
but it comes off vertically instead of horizontally as most trees do, or in scales like a lot of trees do. And then it has white flowers in the late summer. And as the flowers age, the stems of the flowers turn red. And the flowers, so they're and they have a seed pod at the end of that. So that's all bright red. The flowers are white, they're fragrant. And the name of it is usually what I think of before I think of Seven Suns flower, but there's 7 flowers in each cluster, and each flower has 7 parts to the flower, and everything's in sevens. And you didn't used to ever see them anywhere, but now you're starting to see them all over the place. So the first one I saw was at Rauland-Godinez, and it's got trunks this big because it's 100 years old, and now you're seeing them. It begins with an H, but it's not coming to me. They tell you when you're overworked, you lose all your nouns. I seem to not have any nouns tonight. All right, so with our leaf types, we have simple and compound leaves. So a simple leaf is a petiole and a leaf on it, the green part, right? So that's a simple leaf. Just a plain old leaf. Now when you start getting into ID, they're going to ask you about the margins of the leaf, and there's different shapes. These will be serrated, which this one is, but this one's more of a waving serration, whereas some are sharp serrations, and some are the same depth all the way down, and some are multiple depths. So you need to know that. They're going to ask about veins. So some veins will come down, one central vein and the side veins. Others will all stem from the base. So a redbud leaf, all the veins will stem from here. The deciding feature of, this is one leaf is where the bud is. So always look for the bud. And the bud will be right at the base of the petiole where it attaches to the stem. Always. Got that? Don't you love this? That's a Swiss chard leaf. I love those things. Sorry. It's not even a tree. So this is your simple leaf. The bud would be down here where it attaches. This is a compound leaf, and this tricks people because they think this must be a leaf right there. Or if you're really trying to think ahead, they're going to think this is the leaf. But there's no bud here and there's no bud there. The bud will be down at the base. So this entire thing is the leaf. Can y'all think of any trees that have compound leaves? I should have asked. Can y'all think of any trees that have simple leaves? Your favorite tree?
I like redbud. Redbud would be simple.
What'd you say earlier might be your favorite tree?
Well, the sycamore, and then weeping willow would be the compound, wouldn't it? No?
No, they're simple too.
Oh, they are?
They're just crappy wood, so they break off their leaves.
Oh.
Shouldn't say that.
It's a long leaf, is all.
Oh,
Yeah, it's a long thin
Oh, I
leaf.
thought it would just be a longer redbud.
They look like this, but there is a bud at the base of each of those.
Okay.
Okay, so what can we think of that might be a compound leaf? Somebody said the tree you hate.
Locust.
The black locust? You'll have that on it.
And wait, you said the bud's where again?
The
On
bud
the
is
compound?
where, on the compound, it's still where the leaf attaches to the stem. So these pictures don't have the bud, but
Oh,
they're
okay.
down here.
Okay.
So it's not there and it's not up here on each of these leaflets.
Okay.
It's down wherever it attaches to the stem. So when you're asked to identify, you're going to look at that growth and find the bud. And once you find the bud, then you know, is it one single leaf, in which case it's a simple leaf, or if there's multiple stuff on it,
Okay.
then you know it's a compound leaf. So always hunt for that bud. And the bud, when you get into advanced ID, there's different ways that the bud is there. The petiole will wrap around the bud on a sycamore, so it actually protects the bud. There's different shapes there. On the Kentucky coffee tree, it completely encircles the bud, so it's kind of hard to see the bud because the petiole kind of goes over top of it. But it's got this gargantuan leaf scar, so when you look at it in winter, it's really obvious. It's the only thing that looks like that. What is it that makes little monkey faces on the leaf scar? Is that the princess tree?
Walnut does.
Walnut does?
Uh-huh.
So where the veins come through, into the leaf, when the leaf falls off, it makes like a little monkey face of eyeballs and face, smile. I digress. You call that squirrel. This is another form of compound leaf where you have the leaflets going off from a central location. This is called palmately compound. My favorite tree, the paperbark maple, has a palmately compound leaf, but it's only 3 instead of 5. Okay, clear on that? Simple compound. Now we're gonna go take a break. Okay, so we talked about our 3 growing points. So that's our apical meristems, the tips of our roots, the tips of our buds. That's what makes the tree grow bigger. There's lots of growth regulators in those buds. One of the things that we learn about pruning, if we want a plant to be thick and bushy, there's a growth regulator, auxin, that's in the tip, the apical meristem, and it's constantly flowing down the trunk. The bud is always producing it, it's flowing down the trunk. That's what keeps your side buds from breaking dormancy. If you remove that tip, you remove the auxin and allow those buds can break dormancy then. In fruit trees, that keeps buds from turning into fruit buds. So we can do different things. You can pull a branch down and have the tip lower than the branch is, and that keeps the auxin from going down the branch. It stays down in the tip, and so we can get fruit buds a year earlier on that branch by doing that. So there's different things. The other thing, when we're growing our trees, I told you I'm going to trip over that. When we're growing our trees, people want the trunk and then they want lots of little branches on the sides, which we call feathers. Well, to make them do that, we spray that branch, the whip, with a growth hormone that causes those side buds. Actually, it kills the, I'm sorry, I'm telling you wrong. It is a growth hormone that allows those side buds to break dormancy, that forces them to grow. The crazy thing is, as soon as they plant that plant then they cut all those little side branches off so they're this long, but they still want them there. So we can use different hormones and spray those on the tree to create those side branches as well. But those are naturally found in the tips. Then we were talking about the cambium, the vascular cambium, that layer that's right under the bark, and that's what's creating the xylem and phloem. So another thing I used to do was have a picture of a swing, and you'd have the question, is the swing getting higher or lower off the ground? In 20 years, will it be higher or lower? What do y'all think?
Wait, what? Say it again?
If there's a tree and there's a branch on the tree and there's a swing hanging from the branch,
Oh, okay.
in 20 years, is that assuming that the rope doesn't break? Is the swing going to be higher, lower, or the same distance from the ground?
Same, yeah.
And then the second half of this question, is the swing going to be closer, further, or the same distance from the trunk?
Same.
The same. And then there's always some snarky individual that says, well, if the trunk is getting bigger around, which it is, then the swing is going to get closer to the trunk because the trunk's getting bigger.
Well, if it got thicker, it'd actually get lower to the ground.
Exactly. Somebody always has to do that to me. I'm glad to know there's not one in this class.
Yeah.
But, and they're accurate. If the trunk is getting larger in diameter, then the distance between the trunk and the swing will get smaller. But the swing is not growing
No.
outward on the branch. The swing is staying in the same place on the branch. So here we are looking at this again, and I don't remember why. We're talking about annual rings here. So yeah, this is the bark around the outer edge, and then the vascular cambium is that green layer that's right under. So again, it's 3 to 20 cells thick, and it is constantly producing xylem and phloem. And the xylem's going to the outside of the ring, and the phloem's going to the inside of the ring. if you look at the tree in cross section, here is your, the pith of the trunk. And as the tree is growing, this is a branch that grew out, and these rings are actually coming up and wrapping around these branches. And this is it also. So this was the original vein that went to this bud. This bud didn't grow. But that vein is still there, and each of these layers is still wrapped around that vein. One day this might grow. This is where this branch has started growing. The vein is there. Each layer every year, xylem and phloem is wrapped around, and it wraps around the trunk. So as it's growing, this is the branch. One layer will grow the stem up the branch, and the next layer will actually split and grow around it. The next one will grow out the stem, the next layer will grow up around it and keep going up the tree. So it creates this interlocking system, which is what supports that branch as the tree gets bigger and the branch gets bigger. So it's designed to hold those branches in place firmly, securely, strongly, until we start mucking with it. What might cause a bud down here to start to grow?
Something's cut off, like what if like one of the straws or something gets cut off with oxygen and water, maybe it pushes it to something else? I don't know. That's the best I can come up with.
It's when something gets cut off.
It gets cut off.
I mean, oh, near that, like a node, or if you're pruning.
We're gonna hold this thought. Just think about that for a minute, but yes, when you're pruning,
It gets cut off, and in repairing itself, the new cells come out there, and some of those are growth cells.
what gets cut off?
Well, the tip of the bud there,
If that bud gets cut off,
that
it won't,
gets cut off.
it won't
and-
regrow.
No,
Wait, well, say that one more time.
If you just have the bud and that bud gets cut off,
No, but before.
I'm sorry, I didn't repeat him. He was saying if the bud got cut off, then it would cause it to reform and start growing then. I'm not phrasing this properly. This is a dormant bud, and over time, actually, eventually, the bark will grow over that. So it'll be hidden and you won't see those buds anymore. There are times that that bud can be triggered to grow into a branch. So that was my question, which was not properly stated.
If you cut off some of the top?
If you cut off too much of the top, you will cause these to grow. And we'll come to that shortly. This is looking at this cross section again. So you can see where that central vein, that original vein, was coming up, and it goes into your branches. This branch died. This branch died, but you can see the connections here and how these layers are coming up, and then they're actually curving around that branch. Okay, this is another picture of it in real life. This is a weeping willow that one day just decided it was tired of holding itself up, and it just imploded. No wind, no nothing, just so we found out it was completely hollow inside and completely rotted out, but this was a great picture. Here's a branch that broke off, but it's the branch, and you can see each of these layers of the xylem coming around it. So all those are wrapping around that branch to support it. And then we talk about, and we're going to talk about coated, but you see here on this dead branch, it's got this ball right here, which has pushed outward, and that's the tree's attempt to help seal this off, to keep from damaging the tree further. and that's what a little bit of this is. And we're gonna talk about this further, but this is called the branch collar. And that's that wrapping portion around here. The branch collar is very important. The branch collar also has extra hormones in it. It's a ball, a raised area at the base of each branch. Some trees it's really obvious, some trees it's not quite so obvious. And if you cut something around that branch collar, there's hormones in here that will seal over that hole much more quickly than if you were to cut it back here. So you always want to be doing your pruning at the branch collar, and that's where these rings are coming around. So you would cut right outside of this ring, basically. Here's your branch collar, so if you cut right there, that would seal over and cover that wound. When you're looking at a tree, this is a dead branch. The tree has started sending hormones to that branch collar to try to cover that over as quickly as possible. Here's a branch collar on a healthy tree, healthy part. You see that difference in tissue? And that's what you want to see. Sometimes if you have a tree that it's not really obvious where that branch collar is, but I have a branch that broke off right here, or I want to remove a branch for whatever reason. We'll say I wanted to remove this branch, not that I do, but I can't see where that collar is if it's one of those trees. If I cut it here and leave it for a day or two, all this area will swell up and you can see exactly where that collar is.
2 days.
And then you come back, sometimes it takes a week, but the key here is if you're going to do that, because that's a major no-no to cut a stub, you must come back and cut it properly. You're only doing that so it'll raise up that tissue so you can see where the collar is. Otherwise, you always cut it at the branch collar. And if you've done it right, this will turn into a donut. That roll of tissue, that's wound wood, that should be in a nice perfect circle. And then it would look like that with the straight line in the middle once it's sealed over that hole. This was not quite cut properly, so they cut into the branch collar down here, and that's why you don't see that roll right there.
Could you repeat that again about what you said about the 2 cuts?
If you pass this around, you can see this was a cut branch, and you can see how the roll is going around it. So that kind of gives you, this is your wound wood that's covering over that tissue. Got that? I'm gonna pass that around and y'all can throw it to each other. What I was saying was, which cut?
On the right-hand side, that one coming out, you said something about 2 cuts. Make 1 cut and then in a day or a week.
If, on this one, to do a proper cut, you would cut down below, then you would cut, you would cut down below here, then you would cut another cut that removes the branch up here.
Right.
And that gets rid of the weight, and should it split, then it will stop. The bark splits, it will stop at this cut. And then you come back in a 3rd cut and make a nice smooth cut right where the branch collar is. There are some species of trees that you cannot see where the branch collar is. So in that case, you can do your 2 cut, so your cut down below, your cut up above, and then leave this for several days. And the hormones that are in the branch collar will come to the branch collar and cause it to swell. So you can see where the branch collar is. And then come back in a few days. Sometimes it'll take about a week. And come back then and do your 3rd cut where you can see where the collar is. And the reason why, if you cut into the collar, you can see this has wound wood on the sides, but not a whole lot at the top or the bottom, and none at the bottom. They cut into the collar here. And so by doing that, they've removed the hormones right here that would have covered over this hole quickly. And so you get this weird shape. You want a nice round donut. And then once the donut completely seals, again, if you've done it right, you'll see that line right there. That's where the 2 sides of the donut came together. And here is what I'm talking about. This is dead, so the tree has been swelling here for a while, but this, you see how much more swollen this is from that? Can you see where the collar is here? That's kind of what you're doing, but you're forcing the tree to do that on purpose. This tree is trying to cover over this entire dead branch, so it's trying to grow wound wood all the way up this branch. It's a little hard for the tree to do that. It's not nice to make the tree do that. We want to cut a nice, clean, pretty cut right at the collar so that the tree can cover over that hole quickly.
Can you do more than one branch on a tree?
You can. The question was, can you do more than one branch on a tree? We have a rule, it used to be no more than a third of the tree that you want to remove at one time. Now we're saying it's better not more than a quarter of the tree.
Okay.
2 big clumps of grass and 1 giant dandelion. And dirt. 15 by 15 feet square, that was it, and a ladder. So I was getting free plants. I was working for a landscape design company, so when we would take stuff out, I would take home some free plants every so often. And we had a Japanese blood-good maple that had been topped about 50 times. So it was just stubble on the top, and it was hideous, and we decided sometimes if plants were nice, we would keep them and save them and take care of them and nurse them back to health in a little mini nursery health spot, and then put them back out on the job site. But in this case, we all decided this thing was just too awful and we were not going to save it. So we did not put a root ball on it. We dug it out of the ground, we threw it on the trash heap, and it sat there for 2 or 3 days, and I kept thinking, you know, it's a blood-good maple. It's free. I need a small tree. I'd have to pay $150 for this tree if I was to buy one, whereas there's one right there. So after like 3 days, I decided to take it home. And it had about that for roots. So I planted it, I trimmed it up, and this was serious trimming because it has no roots. So tops need to equal bottoms for surface area on the top of your tree is the same as the surface area on your roots. And when they go out of balance, something goes haywire. So if you cut too much top off, you have all that bottom, there's not enough top to support the roots, the plant will start growing out leaves, branches, and that's when those dormant buds start breaking dormancy. The tree is saying, oh my God, I have nothing to feed me. So it starts growing leaves, everywhere it can grow leaves. A tree that is stressed or sick will also do the same thing. As branches are dying back from the tip, it's realizing the top and bottom are not in equilibrium anymore, so now we need to grow more branches to become equal again. So at this point, I got lots of top, nothing on the bottom. So take off all the leaves. Now the leaves, there's the same same amount of surface area because I only left like 3 leaves on it. Maybe 5. Planted the thing, kept it moist, it was doing well, and then it's making branches, and then over the years I was carefully pruning out branches, and I was making sure not to take off more than a quarter because the tree had been so stressed. And again, I'm recreating its shape and its structure and its everything. Well, my mother comes to visit me. And when it's me talking, I am a very determined person. When I'm talking about my mother, she was a very stubborn person. And we all called her the little general when we were growing up. So she was visiting, and so I was going to work, and I was coming back, and my mother had done all sorts of things while I had been gone. One of which was she kept looking at my tree and saying, you've got this big, long, low branch, and that needs to come off because it's in the way. And I said, I know that, Mom, but I don't want to prune out too much because also red blood-good maples are really, really sensitive, and if you prune too much, they start sending out shoots, and I don't want this one to do that because I've just taken all these shoots off, and we're only taking a quarter off the tree each year, and I've already pruned out the 2 branches that I wanted to prune out this year, and I'm planning to prune that branch next year. And she says, no, but that lower branch needs to come off. And I said, I understand that, Mother, but I don't want to take off more than a quarter of the tree, and I've already removed my 2 branches, and I go through the same thing, and I came back home from work the next day, and she cut my branch off. Luckily, it had been long enough, but when you're retraining a tree like that, you need to be very careful, and again, you're never taking off more than a quarter. And in this case, I was trying to take off even less because I knew it didn't have good root structure. So,
This is what the branch bark collar looks like. That was cut off. This is what it should look like. And you can see that little bit of collar around the outside that's raised up and growing. You can also see the branch collar here on this tree. So just to give you another look at that. Okay, the annual cycle. What happens in spring? It gets warm and it rains. And all the leaves are not on the trees, right? So we're gonna start with all the nutrients being in that the tree has ever produced are in the roots. And it rains and we've got all this moisture and it's warm and the tree says, oh my God, I need to make food. So it starts sending everything it can send up to the branches, and to get those leaves to grow out that spring flush, and you'll see several inches of growth of stem. So this will become your branch terminal scar. See those polka dots? Anybody remember what those are?
Lentils?
Lentils? Lentils are beans.
Lentils?
Not close. So it's going to get those leaves open and functioning. And what is the purpose of those leaves? Sorry. It's making food for itself. So we talk about feeding our plants. We don't feed our plants. Our plants feed themselves. We are just putting nutrients in the soil so that they have everything they need after it is dissolved in the water and taken in by the plant. So we got all this growth going on. The plant wants to get the leaves growing. So what's the cool thing about springtime? We know it rains a lot, right? Well, when you have a lot of water and the tree wants to get a lot of moisture to the top of the tree as quickly as possible, it starts making lots of xylem cells, which are straws. Moisture, I got a lot of straws. The straws are all taking water to the top of the tree. The water's evaporating out of the leaves, and we got this whole siphon thing going on, right? What happens when the spring rains stop? On our farm, it's usually the second week of June. All rain halts until September. What happens?
Does it go to the phloem?
It doesn't go to the phloem, and the vascular cambium is still producing straws.
Oh.
But what happens when you have a soda and you're drinking out of the straw and suddenly you're starting to slurp in the bottom because there's not a lot of moisture down there and you're getting a lot of air up the straw? Have you ever tried putting a smaller diameter straw in there? If you put a smaller diameter straw in, you can get some more moisture out until there's less moisture. Then you start getting air again. So you put an even smaller diameter straw out and you can still get some more moisture out. As long as there's a little bit of stuff there, you can keep making smaller and smaller diameter straws and still get some moisture. So that's what the tree does. So when there's lots of moisture, the tree makes big straws. When there's not a lot of moisture, the tree makes little straws. What do you think that does when you're looking at it? Cross section.
Does it literally make more or less straws, or does it make thicker or thinner straws?
Both. It makes less straws and it makes thinner straws. Tree rings? So when you look at tree rings, the thicker, darker, it's that darker ring. The darker ring are the smaller straws, and the lighter colored ring are the bigger straws. So the theory is that you can count your years by counting rings. Because the theory is we have a lot of water in the spring, and then we don't have a lot of water in the summer, and then the next year we have a lot of water, so big straws. The next summer we have a little bit of water, little straws. What happens if we get a whole bunch of water last week, like we did in Harrisonburg? 4 inches 1 week. What do you think the tree is doing? It's making bigger straws, exactly. So we just got a second ring on our tree rings this year.
So it's not a year?
It's not necessarily.
Just
It gives you
roughly?
a nice rough approximation, and they've actually done studies where they've done core samples and they've compared them to weather reports and compared them to weather all over the place, and now they have charts. So they know that in 1928, there was 3 tree rings formed that year rather than 1. And I'm just throwing those numbers out there. And the same deal 2 years ago, 2018, where it stopped raining all year, 1 week. 1 week in June, it didn't rain. That's the year we opened our market. Our market was open from 3 until 6 in the afternoons. And from June, and on Tuesdays and Thursdays, and then all day on Saturdays. Between the beginning of June and the end of September, because I gave up at the end of September, it did not rain on market day 4 times. 2 of those were in the same week in June, and the other 2, it still rained, it just rained in the morning instead of while we were open. Tell me that's great for sales at a farm stand. Anyway, so we had no tree rings that day, that year either, because it didn't stop raining. So everything was big straw sale, right? So that's what creates our tree rings. Okay, summertime. The whole point that the tree wants to do is make food. So in the summertime, all it's doing is making food, and it's doing that by the process of photosynthesis. And in photosynthesis, the plant is taking in 6 carbon dioxide cells, pairing them with 6 water cells, and creating glucose, 12 C6H12O6, and 1 carbon dioxide molecule, 1 oxygen molecule. That's as hard as it gets, I promise. So, and it breaks those cells down, so the 6 water cells, 6 carbon dioxide cells, it uses the sun's energy to break those cells apart, to recombine them into the sugar. Where does the sugar go in the summertime? What's the plant making sugar for? To provide energy for its cells. And it provides energy for photosynthesis to keep happening too. So those cells, for it to grow, that spring growth, we've gotten through the main spring flush, but that doesn't mean those branches stop growing. It just means they slow down. Leaves are out, but that apical meristem is still making more buds and more leaves, just in a much slower fashion. So it needs those sugars to do that. It needs sugars just to create its regular cell life function. So where do you think that glucose goes during the summertime?
Into the soil, back to the roots, back up to the leaves.
A tiny bit goes to the roots and the trunk to support those cells, but it wants all of its energy to stay up here in the leaves. So it can keep on making more sugars. The other place that it goes, the other thing the tree wants to do is make more baby trees. So when it puts out flowers, a lot of sugars go to the flowers. When it's fruiting, a lot of sugars go to the fruit. When the tree is in flower or fruit, that's what it's focused on. It's not making roots. So this is another tip. If you buy a plant, as you know, the garden centers, they put that really gorgeous one right in front, right where you can see it. You try to walk past and it throws itself in your park. It does that. I know I don't pick them up. That really gorgeous one. Don't buy the one that has flowers on it. You're getting your annual display. Get 1 or 2 plants that have flowers on them and make sure the rest don't. Because you want those plants to get established root-wise before they start making flowers. I hear people, oh, I bought a tomato plant and it already had 5 flowers and 1 fruit on it. I'm like, cut them off. Because that fruit's not going to, that plant is not going to grow roots. There's no sugars down there to grow roots. It's going to grow that fruit, that tomato that's already on there. And you've just stunted your plant. It's not gonna grow anymore or much more after that. So don't buy the ones that have flowers and fruit. There was a guy at Blandy actually, and before he came to Blandy, he did this really cool study where he created radioactive carbon. And then he fed the radioactive carbon to plants, which then used that for photosynthesis and made sugars out of, oh dear. Made sugars out of that radioactive carbon, and then they would take pieces off the plant all summer long, all season long, and then put the pieces of plant on photo paper, and the radioactivity in the carbon would react with the photo paper so they could see where all the sugars were. So in the summertime, they're in the leaves until the flowers form, then they're in the flowers, and then they're in the fruit. And in the wintertime, where does all the sugar go? Back down to the roots. So we have our little factory going on up here, and this is just chugging away all summer long. In the fall, the plant says it's going to get cold soon, we're not going to have good sunlight, so I need to shut everything down, and it starts taking all the sugars out of the foliage. And at the same time, the weather is changing, so it's killing off the chlorophyll, which is the other way that we break apart. That's the way we collect the sunlight energy to break apart those cells. And it starts transporting everything down to the roots. Well, oh my God, this plant has grown several feet through the summer, right? Maybe a foot, 6 inches. It's grown. It's been making sugar all summer long, so it's got more sugar at the end of the summer than it brought up at the beginning of the spring, right? It's got to have some place to put it up. Well, conveniently, all those sugars are going down to those root tips. Now those root tips can grow and our roots can get bigger. So roots are growing in the fall, branches are growing in the summer, right? And then in the wintertime, sorry, leaves all fall. I guess that was my winter picture. So in the wintertime, the tree goes into a form of stasis. It's sending a little bit of sugar up the stems to help support the tree, but mostly the tree has gone into hibernation and it's mostly shut down those cells to be the minimum activity possible. So all of those sugars are in the roots. Springtime, we're gonna start all over again. We're gonna send all those sugars back up to the tips. We're gonna start making even more leaves. Leaves are gonna make more photosynthesis, more sugars that it can then store. So if you have a 100-year-old oak tree and you decide to top it in the summertime, what have you done? Because you have removed 100 years of sugar production from that tree. There is no way that tree can survive. If you're going to top, please don't, but if you're going to top, at least do it in the wintertime when the sugars are down in the roots, because the tree has a chance of survival. And I say this, there was a church near our house near where I live, that somebody came and told them their 100-year-old white oak tree was getting ready to fall on the church, which it wasn't, but it was very close to the church. So they came in July and topped it. So they cut off branches this big around, that far from the trunk, and within 1 year, the tree was dead. Lived there for multi years. Okay, coded is that trees never heal. So the plant makes, it's called the compartmentalization of decay in trees. Was that really imaginative or what? Dr. Alex Shiga was the one who started coming up with this. This is the second thing you need to learn in this class. The first one is roots only grow where? Where there's air and water. The second is that trees never heal. When we get cut, we make new cells, we put new cells in that place, and we have everything connected again, and everything's like normal. You might have a little itty bitty scar. When trees get cut, they never reconnect those cells again. All they can do is wall it off from everything else. So we don't ever say that trees will heal that wound. They cover that wound. They seal over that wound. So there's 4 layers, or 4 walls. The first wall, when a tree gets damaged, so we got a bang right here. And so the first thing it does is start sending hormones to those xylem and phloem cells. We don't want any decay to transport those. But remember, we have a little problem with xylem and phloem cells. Xylums don't have end walls and phloem cells have porous end walls, right? So not a very good wall. So you will almost always see decay start to go downward in that tree. The second wall is, down here, the rings. So more hormones go to, more hormones go into those rings to keep the damage from going outward into the trunk. So we can just keep it at the ring itself. The next wall is the rays. So in between the rings, the plant will also create kind of highways that go in towards the center of the trunk. And those are the passageways by which they put the pollutants in there for storage, keep moisture going in there. That's where they put all those minerals and stuff. Those rings are the next wall. And so, rays, I'm sorry, they will send a next set of hormones to those rays to keep things from going around the rings any further. And then the last one is that vascular cambium, where they start creating this roll that goes over top. And eventually that roll will connect and a new layer of xylem and phloem will come up on the outside of that. But that hole will still always be there. So that's why when my willow tree imploded, it was completely hollow inside, it completely rotted out. Willow is a very soft wood, so it's very easy for rocks to go through that. This is another one where you can see there's decay coming in from this. You see that line there, that's where a ring is, and you can see the discoloration that's moving outward, but here it hit a ring and that one held firm. This is a ray, that straight line. These are rays where it's trying to hold it there. And you can see in the areas that it has moved outward, it's almost always in a straight line where it followed out a ray. And then you'll see another ring where it held firm for a while and then gave out again. So it's kind of cool to watch these patterns inside and see how the disease travels. This is a tree that we had at the museum that I tried very, very hard not to cut it down, but I finally had to. This was after it was cut. And this is what's called a ram's horn. So over time, as the vascular cambium keeps creating another layer and another layer and another layer, they'll start to curl in on each other and create these curls. Eventually, it still probably would have sealed over in another 100 years. Unfortunately, we lost one branch on it that came out here that was the balancing factor, and the branches that were left leaned this way and they went over top of a sidewalk, and my board of directors kind of thought that maybe we should not have a tree that is completely hollow and rotted out all the way into the top and all of its branches leaning right over where our visitors walked, and I didn't quite agree. I felt like the tree was better than the visitors, but I lost. So again, trees never heal, but they will cover over and create that roll. This is that branch again where it's trying its best to cover this over. We would rather cut it here where it can cover that wound quickly. Here again is that donut that I was showing. What happened here? It was a bad cut. They cut too close to the collar. You guys will hear more about collars when you get into the pruning. This is our happy cat phase. That's what y'all are all supposed to look like, because now you know that talking about botany and tree biology and all that stuff wasn't as awful as you thought, right? Okay. We talked about everything. Does anybody have any questions, thoughts, suggestions?
Is it possible for tree life to support other tree life leaching off of it? If that makes any sense?
Say that again. Is it possible?
Is it possible for another tree to grow out of one tree and still support both lives without actually having to remove the other? Because I have the rare case at my house where we have a giant oak and there's a pine tree growing in the cradle of it.
Yes, it has happened. I don't know how long it's possible for the pine to be supported by the oak. I have seen one time where the tree, like this apple, was split. This was actually 3 trunks on an apple tree, and the bark collar was included, so the bark wasn't pushing out of the way as the tree grew. So over time, each of these branches are pushing away from each other, and because there's bark in between those trunks, they're not sealing together and growing together and being held together. This one eventually rotted out because of the moisture that was collecting in the three, and that's what's happening with your oak. You've got moisture that's collecting up there, a pine tree seed that landed there and started growing. I have seen one tree that actually grew its root down through the middle and got to the dirt, and so it split, the original tree, but the original tree was still alive, and your other tree was growing up the middle. Strangler figs in the jungle put their seeds there and grow from the crotches of the tree and the tops of the trees down. But then once they hit the ground, then they create a root system there and start growing back up. And they eventually will kill the tree because they grow on it. But I wouldn't take it out,
Okay.
at least for now. More than likely, it won't get to the ground and it won't have enough nutrients to support itself. And eventually the plant will die.
Okay, because I've noticed it hasn't made acorns for like years, so I didn't know if that was dying or what was going on.
Could just be they froze, could be they just didn't.
It could be a lot of things.
And oaks, most oaks are an every other year thing,
Okay.
so there's that too. And one year they froze. So I think a number of the oaks, we haven't had acorns for like 4 years, 3 years.
Okay.
Because they froze on the year they would have been producing.
Huh. It's interesting.
Anything else? Well, you made it through your first night. Yay.